So today what we're going to be looking at is Z-scores, or another term for it is standardized scores. So we use Z-scores because we want to be able to compare different things. So I like to think about it like if you did a test and maybe you got 15 out of 20 in a maths test and you got 18 out of 20 in an English test. Well, it might seem on the surface that you did better in English. But if a lot of people got full marks in the English test and a lot of people did a lot worse than you in the maths test, then it would be that you did better in the maths test. So that is what a standardized score is for. It's so we can compare. So if you read here, it says to gain a comparison between a particular score, like your mark, and the rest of the population, we use a Z-score. So the Z-score, or the standardized score, indicates the position of your score relative to the mean. So a Z-score of 0 indicates that the score or the mark you obtained is equal to the mean. And a negative Z-score indicates that the score is below the mean. And a positive Z-score indicates that your mark or the mean is above the mean. Okay, so the Z-score really is just measuring the distance your mark is or your score is from the mean in terms of a standard deviation. So that a score that is exactly one standard deviation above the mean has a Z-score of 1, and a score that has exactly one standard deviation below the mean has a Z-score of -1. So if I have a look here in this example, I've said, for example, a Z-score of 1.8 means it's 1.8 standard deviations above the mean. So here I've put 1.8 standard deviations above the mean. And in the next example, a score of -0.5 means a score is half a standard deviation below the mean. Now, luckily, we have a formula which is on your formula sheet. And the formula for a Z-score is the score or mark that you get, subtract the mean, and divide it by the standard deviation. And we're remembering that the new way of defining a mean is with this letter mu. So we were looking the other day, if this is my mean, this is one standard deviation above my mean, which means I've got a Z-score of 1. So once more, if this is my mean and I go the opposite way, I'm one standard deviation below the mean, so my Z-score is -1. And a -2 means 2 standard deviations below the mean, and +2 is 2 standard deviations above the mean, and so on. Let's look at some examples. So if I read this question tells me that in an IQ test, I'm told the mean is 100, I'm told the standard deviation is 15, and Amy's taken this test and she's got an IQ of 130, and I've said to calculate this as a Z-score. So writing everything out firstly. So I have my mean, which is 100, my standard deviation, which is 15, and the score that Amy receives is 130. So I'm going to place this into my formula. So the formula is x minus mu over my standard deviation. So placing those numbers in, I'm just going to go to the side because I didn't leave enough room. So I have 130, take away 100, divide that by 15. And the answer that we receive is 2. So that means if I had my normal distribution, here is my mean, and Amy is 2 standard deviations above my mean, and her Z-score is 2. So looking at question 2, I'm going to do exactly the same thing. A sample of professional basketball players give the mean height as 192 with a standard deviation of 12, and Liv is 183 centimetres tall, and I need to calculate her Z-score. So once again, I know my average, my mean, is 192. My standard deviation is 12. And my score, or in this case Liv's height, is 183. So my Z-score is 183 minus 192 all over 12. And I get an answer of negative 0.75. So that means if I have all the basketballers' heights, here is the average here, and that is 192, or the mean. And Liv would be sitting just here at negative, her z-score being negative 0.75 standard deviations away from the mean. So looking now at question 3, we're looking at the average number of hours of study done by students in a class per week, and Jasmine surveys 20 students and obtains the following results. And it says to calculate the mean and the standard deviation correct to 3 decimal places. Well, to do this, we're going to have to pick up our calculators and get them onto statistics mode and work out the mean and standard deviation. So it's going to be a good time to pause the video and to see if you can remember how to do that. To check if you're right, you should get your average to be 14.25, and you should get your standard deviation to be 4.753 to 3 decimal places. And the last part is Jess, which actually should say Jasmine, does 16 hours of study per week and express this as a z-score. So her z-score now is going to be 16 is how much she does, so that's her score, minus 14.25 divided by 4.753. And if we work that one out, we get 0.36818, so 0.368. So looking at question 4, it's just similar. So you can manage 4A by yourselves. Pause the video, come up with an answer. So you should get 2 and negative 0.8. So for doing part B, we're going to now work it backwards. I'm now told the z-score, and I'm going to work backwards. So I'm going to use my formula where I know my z-score. I'm trying to find out what my score was, or how much milk there is, minus my average divided by my standard deviation, which in this case is 5. So working this out, I get 7.5 equals x minus 600. And solving this equation, I get x is equal to 607.5 milliliters. And that was for the first one. You might want to try and do it yourself by pausing the video and having a go. So if you got 587, you know you've done it correctly. And the last question says, what percentage of cartons have less than 590 milliliters of milk? So if we think about what that's going to look like by placing that on a curve, I know that the mean is 600 and my standard deviation is 5. So 5 below gives 595, and then another 5 gives 590. So that is a second standard deviation, or a z-score of 2. And you could have just worked out the z-score if you wanted. So that means I'm interested in this part here. So from our work the other day, we should know that that is 2.35% plus 0.15%. So all up 2.5%. So the alternate way you could have done this is to work out the z-score by using 590 minus 600 divided by 5, and you would get a z-score of 2. So you'd know that the z-score here is 2, 590 is the actual amount, and the z-score here is 2, and it still works out exactly the same way. Looking at this next question, it's just more work on the z-score, just using the formula. So pause the video and see if you can work the z-score forwards and backwards 4 times to come up with these answers. So you should get negative 2, 430, 1, and 436. So all we're doing is using that same formula, the same way we've just used it forwards and backwards. So part B says, what percentage of packets will have a net weight greater than 432 grams? Well, this table, because we've got our z-score of 0, 1 and 2, is really just my normal distribution. So I have 432, one standard deviation above, or a z-score, is 434, 436, and then going the other way, I've got 430 and 428. So the question says, what percentage of packets will have a net weight greater than 432? Well, if 432 is my middle and the normal distribution is symmetrical, that must be all of these scores here, which must be 50% of the scores. For part B, between 428 and 434, well, that's this part in here, this part here, and this part here. So we know from our work yesterday, we've got 34% and another 34% to these two parts here, and a 13.5%. And what that gives me all up is 81.5%. Part C says, if the packets are labelled net weight 430, what percentage of packets will have a net weight less than 430? Well, looking at that 430, looking at that less than 430, I'm wanting this part here and this part down here. So what I have is I have that 13.5% and my 2.35% and my 0.15%. So all up, I have 16%. I hope this makes sense. Thanks for watching.